Today we'll start about the clock divider circuits. That is the F by N clock divider circuit. So mostly like dividers. So mostly, if you see this, this is frequency divider by two. Okay. So this is
Okay.
frequency divider by two. Okay, F by two. So how it will work as F by two means. So you are having D flip flop and q bar is connected as a q bar is connected to D means it is acting as frequency divided by 2. Okay, how it is operating we'll see. Okay, so
Yes.
that means during the first clock pulse what happens, let us take initially q is 0, q bar becomes 1 and D is
One.
1. Okay,
Okay.
so
Huh.
during the passage of clock, during this passage of clock, what happens, uh, q becomes 1, q becomes 1. Why? Because q bar is giving to D, no? This q bar is
Yeah.
coming to D. So q becomes 1 and q bar becomes 0 and D becomes 0. Did you understood this during this passage of clock?
Can you explain once again, sir?
Initially, suppose initially during means before clock is applied, uh,
Hmm.
q is 0. Okay,
Zero. Yeah.
q is 0. What is q bar?
One.
1, no? This q bar is connected to D, no?
So the at the passage the Q will be become one. Okay.
Q becomes 1. Yeah, Q becomes during passage, Q becomes 1. When Q becomes 1, Q bar becomes
Zero.
0. So the 0 will come to D, no?
D again zero. Yeah.
They will come to 0. Okay. Again, during next passage, during next
Again
passage,
Q becomes zero.
Q becomes 0, Q becomes 0, and Q bar becomes 1. This will come to D. Okay.
Again passage it will becomes one. Q.
Next passage, Q becomes 1 and q bar becomes 0 and this will come to
D.
D. Okay, 0 will come to D. Okay, so here
Again next passage. Yeah.
again q becomes 0, D becomes q bar becomes 1 and D becomes 1.
D becomes one. Yeah.
1. So here if you see what is the time period for this clock? T, no?
T.
T. So that means if you see for q time period, this is the time period, no? Let us take this is T dash. T dash is the
Ah,
time period. Okay. So this is the time period. Okay. This is the time period if I consider. So you can consider T dash equal to what? 2T, no?
two T. Yeah.
2T. So you know that frequency is the reciprocal of time, no?
Time. Yeah.
So that means 1 by F dash I can write as 1 by 1 by 2 2 F, can I write?
Uh,
Or 2 by F, sorry, 2 by F. This is nothing but 2 by F. Okay.
two by yeah.
2 by F. Okay. 2 by F. If it is 2 by F means, what is F dash? Tell me F
F
dash.
by two.
F by 2. So that means the circuit is acting as the frequency divided by 2 now.
Hmm.
Did you understood this?
Yes, sir.
Okay, this is the basic clock generated, clock divided by 2. So if you want to divide the clock divided by 2, you need to use D flip flop and Q bar is connected as a Q bar is connected to D and a master clock is given. During the active edge of clock only this output will change. During the passage of clock only the output will change and you are getting the resultant as twice the T. Okay. As this is twice the T, frequency will be divided by 2. Is it fine? Shall I move forward?
Yes. Yes, sir. Yes, sir.
Okay. Next you see. So that means here, suppose if you consider master clock is 1 nanosecond, F equal to what? 1 by T. So that is 1 by 10 power minus 9 means frequency is how much? 1 gigahertz.
1
Okay.
gigahertz.
Frequency divided by 2 means what? Time is what? 2 nanoseconds means. Time becomes 2 nanoseconds, no? So
Hmm.
frequency equal to 1 by T means frequency becomes 0.5 gigahertz.
Gigahertz.
Okay, so this is the generated clock divided by 2 circuit calculation. Okay. Mm, next, so next you need to divide the clock. Our agenda is you need to do f by n, f by n. So n is nothing but a odd integer number. N is nothing but odd integer number. Uh, or we will use for when n is even integer number also, and you will try for when n is decimal. Okay, if you are not getting,
Fine,
I
sir.
will tell you n is decimal. Now I will explain when n is odd integer value and n is even integer value. Okay,
Okay.
so suppose this is mainly for the frequency division. You are using means suppose if you want to divide frequency divided by 3 means you are using mod 3 counter. Mod 3 counter means counters we already seen, no? It will count
Yes,
from
sir.
where 0 to 2. Again it will come to 0, no? If it is
Zero.
modern counter, it will count from 0 to n minus 1. Again it will come to the initial state.
Initial
Okay.
shape.
So here you are using which counter means that is easiest way means you are using that is n equal to 3 means you are using mod 3 counter. Okay.
Not three count.
Mod 3 counter, but what happens, do you know the duty cycle?
No, sir.
Duty cycle is nothing but T on by T on
T on plus T
plus
off.
T of into 100 percentage. Okay.
Yes, sir.
So, like if you see here, mm, that means one second. Yeah. So f by 3, f by 3. Okay. So that means for frequency divided by 3, you are using which counter? Mod
Not
3
three
counter.
counter.
Okay. You are using mod 3 counter. Okay. So you are using mod 3 counter means it will be off for how many clock cycles? 2 clock cycles.
Two block outs.
So this I am taking Q naught. Okay. So this is nothing but my states 0 0 0 1 1 0. Again it will come to 0 0. It will be on for how many clock cycles? One clock cycle, no?
One clock.
One clock cycle. Okay. Suppose if you see the duty cycle, if it will be off for how many clock cycles? One, two clock cycles, no?
Two.
Two clock cycles, and it will be on for one clock cycle.
One
So
clock cycle.
yeah, if you calculate the duty cycle, what is duty cycle?
Two by
T on. T
two
on
by
is
three.
what? 1 1. Duty cycle is what? T
Okay,
on by
okay.
T on plus T off.
T off.
Okay.
Okay,
Duty
one by
cycle is
three into 100.
1 by 3 into 100 means you are getting what? 33.33%.
30%. Yeah.
33.33% when you are using mod 3 counter.
Three counter.
Okay. But you want 50% duty cycle. Okay. So 50% duty cycle means uh, you need to alter the frequency by how much? Tell me.
By
T
two,
on
sir.
T on should be how much and T off should be how much in order to get 50% duty cycle.
T on should be two.
T on should be
T off
2,
should be two.
but it is only 3 clock cycles, no?
Yes, only three clock. Two by three.
3 by 2,
T by two. Yes, sir.
1.5 and 1.5. Is it fine? That is 1.5 divided by 1.5 plus 1.5. So this is into 100. So this is 1 by 2 into 100. You are getting how much? 50% duty cycle, no?
50%. Yes,
So
sir.
you need to alter the frequency by zero point 0.5 times. Okay.
Point
For
five times.
altering the frequency, that means you need to take out this zero point 0.5 from off cycle, means off state, and you need to give it to on state. Okay. So in order to alter that frequency, what you are doing means you are using negative edge trigger D flip flop. Okay. Do you understood? To alter the frequency by 0.5, which flip flop you are using?
Negative T flip flop.
Negative edge trigger D flip flop. Negative edge trigger D flip flop. Okay. Again, these two outputs are given to one OR gate. Do you understood?
Yes, sir.
So here what happens means this is nothing but Q1. Q1 means what? What is the duty cycle? 33.33%. Okay. So this is acting as a input to D flip flop. No.
Ah,
So this is neg edge. Neg edge means just if you want, if you analyze what you are getting means. So here, so during the neg edge of clock, so that means it is going from 1 to 0, and it is going from 1 to 0. So you know that D flip flop is a sequential buffer, no?
yes, yes. What gives the
Sequential,
input same?
yeah, sequential buffer means here whatever the this Q1
Input
is there,
is
this input is 0. Q2 is the output of D flip flop.
okay, then it will be 0.
Same, yeah. Here, same thing, 0, 0. Okay. Here what happens? Here this will be 0 till next negative edge, no?
That's the next negative edge.
During this negative edge, it will check for the input. Input becomes what? 1. Now it becomes 1, no?
1, yeah.
Now it becomes 1. Again, it will check for during this negative edge. So this is the
The
0 means
input is
this is
0. Yeah.
input is 0. This is also 0. And during this negative edge, this is input is 0. This is also 0. And this will be 0 till next negative edge. Okay,
Negative edge, yes.
next negative edge. So here it will check for the input. Input is 1 means the output is 1. Again, during this next negative edge, again this input is 0 means output becomes 0. Okay.
0, yes, sir.
Now what you need to do? You need to do the R operation
Hmm.
of Q1 and Q2.
Q2.
Okay. When you do the R operation, here
0,
till
0. Yeah.
till here 0, no? All are 0, no? 0, 0 means what? 0
0,
only.
0.
0, 0 means 0 only. And here, here 1, 0 means it becomes what? 1. Here it becomes 1.
1.
Okay. Again, here it becomes 0. Okay. Here it is 1 and here it is 0.
This is also
Again,
neg edge of clock, huh?
I'm making OR gate of Q1 and Q2. OR
Q2,
operation.
okay, okay.
OR
Got it.
operation. Okay. So again, here what happens? This becomes what? 1 or 0 means what? 1 only. Okay.
1. 1.
Now you see. So during this clock pulse, that means a 0.5, 1.5, this will be off. Here you see 1.5. This is 1.5. Okay, this is one clock cycle, and from here to here 0.5 clock cycle. So for
0.5. Yes, sir.
1.5 it is on, 1.5
1.
it is off.
Of
How much of duty cycle you are getting?
50%.
50%. Did you understand?
Yes, sir.
Okay. Next, suppose frequency divided by 2. This will be off for how many clock cycles? So
3
you need
clock
to use the
cycles.
mod pi counter. Okay, this is the sequence of mod pi counter. This will be off for 3 clock cycle, 4 clock cycles. This will be on for
1 clock cycle.
1 clock cycle. Yeah, this will be on for 1 clock cycle. Okay, so that means in order to alter the frequency by 1 clock cycle, you need to use passage of D flip flop.
Passage
Understood?
of D flip flop.
Passage of D flip flop. So that means 5 by 2. How much?
0.5. Like
2.5, no?
25%.
So it should be on for 2.5 time units and off for 2.5 per time units, no? So you need to take
Yes.
out how much of clock cycles from 4,
We
and
have
you
to
need to
take out
add,
1.5.
yes, you need to take 1.5. So that means zero point 0.5 is for negative edge trigger D flip flop, and one more 1 clock cycle is for positive edge trigger D flip flop. Did you understand?
Yes.
So here you are using, that means this is a positive edge trigger D flip flop, and here negative edge trigger D flip flop. Negative edge trigger D flip flop. Is it fine? Okay.
Yes, sir. Understood.
So so here you are using two flip flops. No. Suppose I want to reduce the circuit complexity. Is there any alternative option?
Instead of flip-flops, sir.
Here I am using two flip-flops, no? I don't
Hmm.
want to use two flip-flops. I want to use only one flip-flop. Any other alternative option in this?
Don't know, sir.
Here, in order to see Q2, can I take Q1?
Hmm.
Q1 means what? It is off for 3 clock cycles and this is on for 1 clock cycle.
2 clock.
Two clock cycles. 2 clock
Two
cycles
clock.
means I can take out zero point 0.5 from here. I can use only one negative edge trigger D flip flop. No?
Yes, sir.
Okay. So see here. So in order to, so we need to do the optimization. So in order to take Q2, we need to take which one? Q1. Okay. If we are taking Q1, you need to use only one negative edge trigger D flip flop. Did you understood how to optimize the circuit? Is it fine?
Yes, sir. Understood.
Understood. Okay. So that means what is conclusion? We need to include modern counter. If it is positive edge trigger trigger flip flop, we need to alter the frequency output frequency by alter the output by 1 clock cycle. If it is negative edge trigger flip flop, we alter the output
All
by
this is
half clock cycle. Need to choose modern counter. Output of modern counter having f by n. Okay, less alteration is
yes,
required for hardware optimization. Is it fine? This is the conclusion. Shall I move
yes, sir.
forward? Oh, yeah.
Yes, sir.
Suppose if it is f by 7. F by 7 means 7 by 2. It is 3.5.
Keep on.
So this
Why
is
always two, sir? It like
duty cycle.
ah duty cycle. Okay, okay, got
50% duty cycle. 50% duty
it.
cycle means what? It should be on for 3.5 clock cycles and it should be off for 3.5 clock cycles.
Okay,
So
yes.
what is duty cycle? T
T
on by
on by
T on plus
T on is T off into 100.
100. So need to get 50% duty cycle. Okay. So here this is off for how many clock cycles? 4. This is
Oh,
on for 3.
3.
So I need to alter by how much?
0.5.
0.5. You need to take out 0.5 from here. So for that you are using negative edge trigger D flip flop. Is it fine?
Yes, sir.
Okay. Next. This is frequency divided by 2. Okay. So you are using which counter? Mod 2 counter. Okay. So mod 2 counter means 0. It is off for 1 clock cycle
On,
and it is on for
on
1
for
clock
one
cycle. So how much of duty cycle you are getting?
percent.
50%.
Sorry.
50% means 50%, no?
Yeah, 50%. 1/2.
50%. Yeah, 50%. 50% means no need to apply the negative edge trigger D flip flop or positive edge trigger D flip flop. Simply you design with mod 2 counter.
Down count. Yes.
Okay, understood? Shall I move forward? Hello.
Yes, sir. Understood. Yeah, yeah.
Oh, yeah. So suppose if it is f by 4. F by 4 means what? This is off for 2 clock cycles and off for on
On
for
for
2 clock
2.
cycles. So here also you are getting 50% duty cycle, no? No need
So
of
we can
external
directly with mod
directly
4 count.
mod 4 counter. Yeah. This is mod 6 counter. Mod 6 counter means if you see Q2, this is off for 4 clock cycles and this is
On for
on for
2.
2 clock cycles. 2 clock cycles but 6
Hmm.
by 2. You need how much? 3 off and 3 on, no?
Uh,
So you need to alter the frequency by one output frequency
1
by 1
clock
clock
cycle.
cycle means
So
you
we
need to
have to
use
see positive edge trigger. Hmm.
positive trigger D flip flop. Is it fine?
Yes, sir.
This is for even numbers.
Even
Okay.
number.
This is for even numbers. Okay. So this is about the frequency divider circuit. Any doubts or queries related to frequency divider circuits?
No, sir.
Okay. So why we are using the frequency divider circuits? No, means when you are going for system on chip or IPs, okay, all
Hmm.
modules will not work in same frequency. So we need so many frequency dividers such a way that we need to distribute that clock to different modules. Is it
Hmm.
fine? Okay. Uh, Next is ring counter. Ring counter. So what is this ring counter? For this ring counter, I told you the asynchronous inputs. Did you remember what are asynchronous inputs?
Synchronous inputs, it's like despite of the clock, it will if it is one, it becomes one, or else it will be zero. It will be
What
zero.
are those? What are those? Did you remember? I told the
No, sir.
asynchronous inputs.
That asynchronous inputs, yeah.
Uh, Preset and clear. I told no.
Preset and clear, yeah.
Preset and clear. Preset means what? When
It
preset is
will reset
activated, it will force the output to
it
one.
one. If it is clear, it will be zero.
It will force the output to zero. Okay. So in the ring contour, what you are doing means this preset is there, no? So this preset is applied to the input of first flip flop, and clear. This clear is there, no? So clear is given to other three flip flops. Other three flip flops. Okay. So that means first flip flop always set to what one. This first flip
One.
flop will set to one, and remaining three flip flops will clear to
Zero.
0. Okay. So what is my state? Q0, Q1, Q2,
Q2,
Q3.
Q3.
That is equal to 1, 0, 0, 0. Okay. So I will draw the ring counter by using D flip flops. How many flip flops I am using means 4 D flip flops I am using. Okay. So 4 D flip flops. Here, first flip flop is given to preset, active low signal preset. Okay. And as this is a synchronous sequential circuit, common clock is given to all the flip flops. Common clock is given to all the flip flops. This is passage of clock, and this is D naught, Q naught, D1, Q1, D2, Q2, D3, and Q3. Okay. So D naught is connected, Q naught is connected to D1, and Q1 is connected to D2, and Q2 is connected to D3. Again, this Q3 is there, no? So Q3 will be feedback, and that is given to D naught. Okay, and this one more signal, that is clear signal, is there, no? So clear signal is connected to remaining three flip flops. Did you understood the diagram?
Yes, sir.
Okay. So suppose if you draw the diagram means table Q0, Q1, Q2, Q3. Okay, and you are giving the clock. Okay, initially when clock equal to initially you are not applying any clock. What is the output values?
If initially clock is not applied, then it will be zero, 1 0 0 0.
1 0 0 0. Okay, 1 0 0 0. After that, first clock is applied. First clock is applied. What happens? So initially, yeah, right, I'm writing. So initially, this is one
One.
second. Uh, this is one. This is 1 0 0 0. Okay. Again, first clock pulse, what happens? This 0 will come to D naught, no?
D naught, yes.
So 0 will come to D naught means this becomes 0. This will be shifted. This 1 will
Shifted to
come here
1,
and this will be
0,
0.
0.
So this is 0, 1,
0, 1, double 0.
double 0. Okay. At second clock pulse,
0, 0, 1, 0.
0, 0, 1, 0. Okay. At third clock pulse,
0, 0, 1.
triple zero one. Yeah, triple zero one. At fourth clock pulse,
Comes to the same position like
the same position. Yeah, it will come to the same position. And at fifth clock pulse, same it will
again it
repeat. No,
repeats. Yeah.
repeat 0 1 0 0. At sixth clock pulse, 0 0 1 0. At seventh clock pulse, again it will come to 0 0 0
1.
1. Okay. So it is like a ring, no?
Yes,
It is
sir.
acting like a ring, no? Ring count. That's why we call it ring count. Okay. This is nothing but ring count. Is it fine?
Yes, sir. Understood.
Understood. And next is Johnson counter. Johnson counter. Okay. In the Johnson counter, what you are doing means whatever the last flip flop complemented output is there. Complemented output. Complemented output is there. That is Q bar. Okay. Q bar is fed back to the input of first flip flop. Input of first flip flop. First flip flop. Okay. So for 3-bit Johnson counter, 3-bit Johnson counter, there are 3 flip flops we are using. 3 flip flops I am using, which we can make mod 6 counter. Which counter? Mod 6
Not
counter.
6.
Mod 6 counter. Okay. So how we can design means you are using 3 flip flop, 3D flip flop. 3D flip flop. D0, Q0, D1, Q1, D2, Q2, and this is Q2 bar. And a common clock is given to all the flip flop as this is the synchronous sequential circuit. Common clock is given. Common clock is given, and Q2 bar is acting. It should be feedback to the D naught. Okay, and Q naught is given to D1 and Q1 is connected to D2. So here I am writing clock. Okay, clock, and next Q naught, Q1, and Q2. Okay. Initially when clock is not applied, okay, when clock equal to 0, so what happens, the output of all flip flops will be 0 only.
0.
Okay, these all flip flops will be 0. At first clock pulse, what happens? This is 0 means this becomes
1.
1,
So
no?
1 double 0.
1 double 0. 1 double 0. This will be shifted. 1 double 0. And second clock pulse,
T is again 1. Same it goes now, sir. 1 double 0. Shift.
shifting operations happens. 1 will come here. That means
Hmm.
whatever the Q naught is there, that is D naught. This will be shifted. This 1 will come here and this 0 will come here. So that is 110. Did you
Again
understood how it
triple
is happening? And next triple one.
1.
Triple one.
Again it becomes 0.
Hmm,
0 double 1.
0 double 1. Next
0 0 1.
0 0 1. Next
Triple 0.
0 triple 0. Again
Again 1 double 0.
1
Again
double
it
0. Again double 1 0.
1
Okay.
double
So here what happens? At sixth clock pulse, it will coming to the initial state now.
Mm.
So can we say that this Johnson counter is March 6 counter now?
Yeah.
It is counting from where to where 0 to 5.
So 5.
After 5, it is coming to the initial state. Whatever the initial state is that is coming. Okay. So this is also one interview question. Which one is acting as a March 6 counter means uh,
Johnson count.
Johnson counter. Okay. Is it fine?
Yeah.
Next, RAMs I need to tell. SRAM, DRAM.
I'd go through it, sir.
You will go through this. Okay. If you
Mm.
are understanding means okay. Otherwise, please ask me. I will explain about the SRAM and DRAM. Okay. I shared the notes and all those things. No?
If you can get the time, I'll just go through it.
Okay. Okay. 1 second.